On this episode of Indiana Expeditions, we investigate green science. It's a term that's becoming more and more popular these days. Green science is all about being efficient with our resources. We'll take a look at the many ways people can go green.
This is green science.
Follow me. It's time for another expedition.
Indiana Expeditions with Rick Crosslin is made possible through the generous support of the Eli Lilly and Company Foundation, dedicated to improving the lives of patients and the communities we serve. The Dr. Laura Hare Charitable Trust, enhancing Indiana's natural environment through preservation and protection of ecologically significant natural areas, and promoting environmental education, stewardship, and awareness. And the Indiana Academy of Science, serving Indiana science since 1885.
So what is green science? You hear the term all the time. Green science is the science that allows us to do things with less impact on the environment and the people around us.
Did you know green science integrates earth, life, and physical science in an effort to study ways to solve environmental problems?
There are a lot of ways to go green, and some of them are pretty simple. Here's one way that you can make a difference, one light bulb at a time, to save energy. I have two light bulbs that give out the same amount of light energy. One is a compact fluorescent and one is your typical incandescent light. This is a meter that measures how much electricity flows into your house. The more things you turn on, the faster this goes. And every time it spins, you're charged a little bit of money for that energy. So let me show you what happens when we turn on a compact fluorescent, which is an energy saver bulb. And let's see how that wheel spins. It's spinning kind of slow, and that's a good thing because the slower it spins, the less energy it uses. Now when I switch over to one of the traditional light bulbs, an incandescent, we're going to get the same amount of light. However, that wheel might do something that will surprise you. And what it is doing is spinning a lot faster because that type of light draws more current, gives you the same amount of light, and there's another advantage to having the compact fluorescent. This bulb gives off heat energy that's wasted up in your house, while this one is a much cooler and most of the energy goes into light, not heat. One way that you can make a difference, one light bulb at a time. The only way we can make a difference is if we all make some changes. Making changes can be fun too. Students all over Indiana are finding better ways to be efficient with their classroom supplies. One class is even making its own paper.
Today we decided to make recycled paper in our Going Green lesson.
We're going green!
We are talking about different ways to reduce, reuse, recycle, and show them that science is for everyone and it's fun and we can help the planet while we do it.
Okay, boys and girls, who can remind me what are some of the things we've been talking about lately about going green and doing less harm to the earth? What are some of those things we've been talking about? Just a quick review.
Where on earth does all of this garbage go?
Where's it go when you throw it away?
Summer farm.
Yeah, maybe even in your own backyard.
In order to do this lesson, we started off cutting paper that we had already used for something else. We cut it into little squares, and then we soaked it in warm water for about an hour. The students were mixing it with a whisk while it was soaking. And we put it in a blender, and we added food coloring for fun.
Like green.
Green, you guys like green?
Green, that's a good color for green science.
Look at our color. This
mean, it doesn't get much greener.
We're pretty green. Okay, the next step is we are going to add some cornstarch. That's going to help our mixture get really gooey. Then we poured it onto the screen, try to mush out the excess water a little bit. And then we flip the screen over onto a towel, and we could blow dry it or iron it, or you could just let it sit and dry on its own, but it would take much longer. And it should be ready to go tomorrow for the kids to bring home or work on projects here.
Great job. It's very important for students to not only be able to write about science, but to be able to do science. I mean, you can read about it in a textbook, but that's not real. Kids need to experience it. Once they've experienced it, it makes writing so much easier.
The kids really like this lesson because, well, first of all, they really love to get messy in school and mess up the classroom and not have to worry about things like that. But also, we've really been studying about going green and helping the earth, and so they really love doing things where we can help the earth. So using the recycled paper was a way to kind of get them started with that. When you do hands-on science, there are so many rewards. To see the children get so excited and for them to smile and just be excited to learn and excited to come to school, it's very much worth the prep time for it.
I made these last night with Mr. Lozier.
What I love the most is just the joy of teaching and coming into the classroom every day and just seeing their smiles each day and getting the hugs as they leave and knowing that really just making sure that school is fun. I had some grades where I didn't have very much fun in school, and I don't want my students to ever feel like that.
Well, Mr. Crosslin, this piece of paper, since you were nice enough to come and have us on your show, we're going to give you our first piece of recycled paper for you to do what you want with it.
And I know exactly what I'm going to do with this paper.
Everyone.
These third graders can look forward to more of the same as they get older. They will be the next environmental engineers, or even green race car drivers. This is the Super Mileage Challenge, held every year at O'Reilly Raceway Park. Today, student teams from high schools all over Indiana have converged here at this world-famous racetrack.
It's 100% student made, student design.
It'll just take off.
The goal? To have the most efficient race car out there. I'm here at O'Reilly Raceway Park where the Super Mileage Challenge is underway. It's a beautiful blend of green science, green technology, and green engineering. What kind of brakes do you have on these brakes? Are just regular hand brakes?
They're kind of like bike brakes.
It looks like a lot of troubleshooting. What are these guys working on back here?
Trying to get the gas tank back on.
Now, it seems like there's all guys here. Is this only guys allowed in this class?
No, there's 3 girls.
I put the entire body on the car.
What kids do is they go through a design process in the fall to make a proposal to design a vehicle that'll go well over 1,000 miles per gallon. What they're using is a traditional 3.5 horse Briggs & Stratton engine, and they're maximizing what they can do with that, and also using advanced materials such as carbon fibers and aerospace materials.
These vehicles were designed from the ground up by students.
A lot of it is basically taking ideas from the students' heads and putting it into a form of application to maximize what they can do.
Each school has a team with members focusing on a certain aspect of the car. There are team mechanics, engineers, and drivers, all working together to win the race, just like the pros.
Joe, are you timing it?
Personally, I like being hands-on, more stuff, but you always have to start little, learning about it, and then you can come out here and keep improving it year by year, building off ideas of everyone. New kids in the class coming up with new ideas.
And we thought it was condensation.
Well, it provides them experience with applying what they know and what they can do. It also provides them with experience, being on a real racetrack, and it gives them also some experience in the motorsports industry, which, with Indianapolis being one of the capitals of the world for motorsports, why not do it here? The resourcefulness of the kids also, comes up with, why some of these teams that look like they're super high dollar might not be as much as you may think.
These students really make me look good because I know nothing about the math and the physics behind it. And we're set up where we're a fully student-led class, and my job is just to guide them and be there for safety.
You can tell they have a lot of ownership in this, and they seem like they give you a hard time too, especially these guys back here. Are their grades still safe for this kind of time?
After today, I'm unsure about their grade, to be quite honest. Seniors kind of pass down their ideas to the juniors, and then when the juniors are seniors, they pass it down. And they take one idea and they improve on it and expand it. You can come thinking that you're 100% prepared, and the next thing you know, something happens and you're starting all over on the drawing board.
That's how the engine lights in.
One of our screws came out of the filter, so it was all sucking air, so it wouldn't work. Got that fixed, and then it wasn't idling, we just got that fixed, so hopefully look for a good run.
Some teams even use GPS for testing and headsets for communication. Many of these kids will go on to pursue a career in this field, and by getting an early start like this, the possibilities are endless.
Did you know the world record for miles per gallon driving a car is over 3,000 miles?
One popular green tech solution is to use solar power to do things. Solar power is using energy from the sun. If you add up all the energy that's ever been produced, that still doesn't amount to the energy that comes in one single day from the sun. Right now, the best way we can use this energy is through the use of solar panels. A solar panel converts the sun's energy into electricity. To learn more, we caught up with ECI Wind and Solar.
We design and install renewable energy systems. With the sun, I have two choices really though. The sun's warm and I can collect the heat from the sun, or I can use a chemical process that takes the energy from the sunlight and turns it directly to electricity.
This chemical process is done using something called a photovoltaic cell, or PV cell. The sun's energy hits the cell. These PV cells are made of a semiconductive material like silicone. When sunlight hits a semiconductor, electrons inside the material are disturbed. This disturbance can push an electron along a conductor. If a PV cell is tied into an electric circuit, the sun's energy can be converted into electricity. The system here at Cool Creek Nature Center generates electricity for the park.
One of the great things about this is it's our first solar project for Hamilton County Parks and Rec.
This solar system is enough to power the visitor center and more.
If the PV array produces more electricity than the building is using, it will take that extra electricity and send it back to the grid.
People are even starting to explore using advanced green technology at home. And with the right setup, electric companies might wind up paying you for the electricity you generate.
You can have a house that can completely sustain itself using solar energy.
When it comes to going green, this family is above and beyond. They have a wind turbine and a massive solar array for the house. I'm green with envy. When the sun strikes this, that radiation is converted through these silicon cells into electricity that is sent to the house. This farm gives new meaning to the name Green Acres. You know, we're used to seeing windmills on a farm, but llamas? Here at the Children's Museum, we're doing our part to go green. One of the changes is that we have created a rain garden that collects the water off the building into this area to soak down into the aquifer, not the city sewers. But this is just one change of many.
Today is kickoff to Earth Week celebration.
Its name is Pachosaurus digitus.
Here at the museum, we are trying to be more green, but also I think a lot of people don't realize how many organizations can provide assistance, educational materials about being more green and being environmentally friendly.
I'm here at one of the Children's Museum's family programs where they're making rain barrels. Hold on. You're making a rain barrel? Where'd you hear about this idea?
Her.
Her? Who's her?
My mom.
Your mom. Okay, so what are you going to do with this at home?
We're gonna get water so we can water our plants.
So you can water your plants, okay?
And fill up our water gun.
And your water guns too, okay. That's kind of a cool way to do it.
Families take home what they've done here, and they continue the discussion at home.
Okay. So, when it rains, rain will come down through the gutter, and we have holes drilled into the top of the rain barrel so that rain can get through, and there's a screen underneath the lid so it can keep bugs and seeds and all that kind of stuff out. And eventually this will fill up with water, and then all we need to do down here is hook a hose to it, open it up, and let gravity do the rest.
You can just use rainwater for your garden, and I heard that rainwater is better for your garden than any other kind of water.
That's pretty cool. Not only does that save the water bill, but it also makes better use of the rainwater, I think.
Yep.
At this house, all the rainwater goes where?
In here.
I'm here at the Children's Museum of Indianapolis with one of their cool projects, the Green Rooftop Garden. You've probably noticed many changes to the outside of the museum. A family of dinosaurs have come crashing through. On your next visit, look for the new Schaefer Rooftop Garden, just below the sunburst window. Hey Nick, how you doing?
Doing well. How you doing, Rick?
So you're the project manager of this system here.
Yes, sir.
All right, let's check it out.
Absolutely.
Nick Churchill is supervising the transformation of a roof into a gorgeous garden. It will help the environment, help living birds and insects, help the Children's Museum cool down or heat up, and look beautiful to visitors. Roof gardens are becoming popular because rain that runs off buildings waters the plants. That's how the environment is helped.
Because that stormwater is retained and used, it doesn't find itself being ushered through a traditional stormwater system and into the storm sewers where it becomes a problem for the city to manage and ultimately all falls in the river itself.
Water can't leak into the building because a special waterproof membrane is put down first.
On top of that slip sheet, we place the modules themselves as well as the ballast stone for the perimeter walkways. It's actually a pretty complete system, and we're really a big fan of it.
A computer-generated map tells Nick exactly where each specially grown module or container of pre-grown plants needs to be placed. This is the heart of the project. These sedums are planted in a recycled tray, and this is what makes the green grid system.
Once this is fully grown out, you'll see a stark contrast, and it'll be pretty amazing.
Hi, Kara. I understand you know a lot about these plants.
Yes, I do, Rick.
Well, let's learn something.
Okay.
Kara Cribbs is a biologist who selected special plants for this garden. They are all forms of a genus called sedums. Their leaves suck up the water and save it.
You know, if it's 90 degrees outside, it can be 120, 130 degrees on the rooftop. These species are actually native to rocky outcrops or alpine environments.
Will these plants help the environment?
Absolutely. These plants actually create habitat. I've seen several birds on the rooftops, you know, taking spent blooms and heading off to make their nest.
Is there any soil in here? Because this looks kind of like a haydite of some kind of a material.
Exactly. You're right, Rick. This is actually an expanded clay-based aggregate. It's about 95% inorganic to about 5% organic.
So Kara, I'm looking at this map. This relates to the plants?
Yeah, we basically used 5 different mixes here, and within the sunburst window here we have 4 different highly contrasting mixes of yellow foliage, red foliage, purple blooms, and yellow foliage.
It's going to have a real living sunburst.
Absolutely.
We've seen how reuse of the water will help the environment and how the plants will attract bugs and birds. But how will this garden help the Children's Museum building? By turning a previously black roof that retains heat into a cool green one. When water evaporates, it takes heat out of the system.
That's exactly right.
And so will this affect what's going on inside the building?
The heating and cooling of the area below will be affected by this in a positive way.
Now that this green roof terrace is finished, it's starting to grow on me. In fact, it's doing exactly what it was designed to do. It's providing habitat for insects and bugs. It's lowering the heat down inside the museum, and it's catching rainfall. And on top of all that, it looks beautiful. Another green science idea is to use energy inside the earth for heating and cooling. It's called geothermal. Below the Earth's surface, about 250 feet down, the temperature is at a constant 56 degrees Fahrenheit in the summer and in the winter. We can use this to our advantage. By drilling down and installing pipes that can carry liquids, we can essentially cool things off when it's too hot or heat things up when it's too cold. By exchanging hot liquids or cold liquids depending on the season. Areas all over the world take advantage of geothermal energy, but Indiana has one of the best examples in the works. Over time, this investment will pay for itself. I'm here at Ball State University, where I hear the nation's largest geothermal project is going on. In fact, heat exchange pipe buried below. I must be pretty close. Let's go check it out.
It is both environmentally and economically friendly. When it is complete, will save us $2.3 million a year.
Hey Jim, I'm here to learn about your project.
Great, Rick. Come on in, I'll show you.
So Jim, we're right in the middle of a construction site above ground, but all the energy is below us?
All the energy is below us, but to get to that energy, these rigs have to drill 400 foot into the ground, 6 inches in diameter, and insert the tubing that will carry the water that will take that energy out of the ground. Any part of the world can use geothermal. The mechanism by which we can provide heating and cooling at the same time is built into the heat pump chiller that will be purchased. That system will operate off a refrigerant cycle that literally, its job is to make chilled water.
Okay.
And that heat of rejection from the chilled water is going to be moved over to help make hot water. And that's how this works.
This is one of the 4,000 plus boreholes that's going on right here. What we have are 2 sets of pipes just like this, where the water goes in and comes back out to exchange the heat. Took a lot of energy to put this in, but it'll save a lot of energy in the future.
As you can see, they're attaching all the boreholes together, the supply and the return side, for what will be a completed area. And when the attaching or the welding of the pipe is finished, as you can see above us, or will see above us, all this will be backfilled and a parking lot will be on top of here. With our new system, we pay $1 for energy and we get $8 back. That's quite a return on investment.
Wow. So the heat that will naturally occur in this energy transfer, instead of going out of the building, you want that because you want to use that heat back in your system in reverse.
Absolutely. I want the heat off the lights, I want the heat off the computers, and I want you. I want the heat off of you. You're an energy source.
I can see a day where I want to charge you to come in your building, Jim. If you want my heat, it's going to cost you lunch.
Did you know geothermal energy gets its name from 2 Greek words, geo meaning earth and thermos meaning heat?
When you think about green science, you usually think about forests or the outdoors, but I know a place right here in downtown Indianapolis that's all about green.
Hi, welcome to the Nature Conservancy, the Ephraimson Conservation Center. The Nature Conservancy is an international, not-for-profit conservation organization, and our mission is to protect the diversity of life on Earth. This building is really the living embodiment of our conservation mission.
Thank you.
And Eric Anderson.
Access Architecture. Nice to meet you.
Eric designed the building.
We right now have designed the building to use 35% less electricity than a normal building on the site. We've also designed the project to use 40% less potable water than a normal building would on the site. Being that the building itself wasn't any more expensive than a normal building, we're seeing savings from day one.
Funds that would go towards maintenance can now go to preserving the environment. They do this by using passive strategies, such as wooden slats that shield the windows on the hottest days, and by using reflective surfaces and good design to utilize the sun during the day. Even in the basement, which has an outdoor green space covered with native plants. Living wall, pretty cool. When it is necessary to use lights, they are occupancy triggered and dimmed to only use the amount of light needed. Heating and cooling is not only enhanced by efficient use of windows, but it's also supplemented by geothermal wells. Distributions of that air is made more efficient by locating the ducts on the floor.
And by doing that, that puts the air at the human level where you need it.
Additionally, there is a green roof that helps insulate and cool the building. The need for water is reduced by collecting and storing rainwater that is used for flushing toilets and watering plants. This building also uses a bioswell, which is a system for collecting water runoff and diffusing it naturally back into the ground.
One of the things that we have found out during this whole process is that we will save the city $600,000 over 30 years because we aren't piping that water into the storm sewer.
The materials used in this building come from a variety of recycled sources, but the best green product is to use no product at all. So where flooring is not needed, it's not used. These innovations have gained national attention through the Green Building Council's LEED program.
What that is a process for construction to design and construct buildings that are sustainable and friendly to the environment.
This building has become the first platinum level LEED building in the city, and it's turned a lot of heads. Achieving the highest level of LEED certification is quite an accomplishment on its own. But the Nature Conservancy is already planning for the future, where they will make their own power. In this episode, we've learned many ways to apply environmental science to improve our daily lives. The goal of being sustainable is not easy to reach, but if we all work together to make small changes, that will be one big change for the environment. I'm Rick Crosslin. Join me on the next Indiana Expedition.
Indiana Expeditions with Rick Crosslin is made possible through the generous support of the Eli Lilly and Company Foundation, dedicated to improving the lives of patients and the communities we serve. The Dr. Laura Hare Charitable Trust, enhancing Indiana's natural environment through preservation and protection of ecologically significant natural areas, and promoting environmental education, stewardship, and awareness. And the Indiana Academy of Science, serving Indiana science since 1885.